Hello and welcome back to this course, covering the exam topics for the JNCIS ENT certification. In this section of the course, we're reviewing ISIS concepts, configuration, and monitoring in Junos. In this lesson, we'll be reviewing the commands and outputs needed to monitor and troubleshoot ISIS on Junos devices. We'll take a look at router R1, which is directly connected to R2 via GE000.0. These routers are both configured as Level 1 routers in Area 49 and are not connected to any other ISIS-speaking routers. We'll review the commands needed to validate the interface status for the interfaces participating in ISIS, the status of the adjacency between R1 and R2, the LSP database contents, and finally, the statistics information available. So, let's jump in and start off with validating the status of the participating interfaces on R1. The show ISIS interface command, as seen at the bottom, will list the interfaces on the local device which are participating in ISIS, and to what extent. The loopback interface is showing to be a passive interface for both Level 1 and Level 2. A passive interface, like in OSPF, is one whose network is advertised into the protocol. However, the interface will not originate IIH PDUs. This is as we would expect, since the loopback interface has no need to originate any IIH PDUs. From the right in this output, we have the metric that is assigned to each interface. This is the cost of the link used when performing the shortest path computation for destinations reachable over that interface. The next column left would list the Level 2 designated router, or designated intermediate system for the broadcast segment attached to that interface. This can be different from the Level 1 designated router on the same interface, as both Level 1 and Level 2 adjacencies may be formed on an interface by default. In this case, we see that Level 2 is disabled for this interface. The router has been configured as a Level 1 only router, as we saw in the diagram. The next column left shows the Level 1 DR for the broadcast segment. This is indicating that it is R1, and specifically the circuit ID 2, as indicated by the .02 shown after the hostname. We can confirm that circuit ID 2 is this interface in the next column, where we have the circuit ID listed for each interface. The next indicates the level that the interface is participating in ISIS. The loopback interface is showing a level of 0 because it is not originating IIH PDUs for any ISIS level, whereas we see that GE000.0 is only participating at Level 1. And finally, we have the interface name. In the output above, we can get more details about each interface if we add the detail flag to the show ISIS interface command. Here, we have some details like the hello and hold timers configured, which are at their defaults currently of 3 and 9 seconds respectively, and the number of adjacencies formed on this interface. Now, let's take a look at the details of the adjacencies that are formed. Using the show ISIS adjacency operational mode command, we can see some summary information about each adjacency that is formed from R1's perspective. We have the interface that the adjacency is formed over, the hostname of the remote system that we've formed an adjacency with, the level of the adjacency, the current state, the hold time remaining before the adjacency will be considered down if an IIH is not received, and finally the SNPA address, or the subnetwork point of attachment, which is the equivalent of the MAC address. As we see in the output below, the SNPA address is actually listed as the MAC address in the detailed output. The detailed output also gives us some other very useful information. We can see the number of up-down transitions seen for this adjacency, and when the last transition from up to down or down to up had occurred. We can also see the capabilities of the adjacent router. In this case, it will exchange LSPs for both IPv4 and IPv6. Now that we've reviewed the details of our participating interfaces and adjacencies, let's take a look at the contents of the LSP database on R1. Using the show ISIS database brief operational mode command, we can see the high-level contents of the ISIS LSP database on this router. As we expect, we only have level 1 LSPs in the database, as we do not have any level 2 routers in the domain. And even if we did, we would need to explicitly leak level 2 LSPs into the level 1 area if we wanted. The information here can be useful in troubleshooting. If perhaps some unexpected behavior is seen, we can see the ID of each LSP on the left, indicating the circuit ID and hostname of the originating router. This output, however, doesn't show us any information on the contents of the LSPs in the database, only the header information. Let's see how we can view the contents and network reachability information contained in each. Adding the detail flag to the show ISIS database operational mode command, we can see the contents of the LSP database on R1. Here, we see the metric and prefixes contained in the ISIS LSPs of the database. We see the details for the 3 entries from the previous slide. The LSP from R2, as we learned in a previous lesson, will describe all of the adjacencies and directly connected prefixes which are participating in ISIS. We see that the LSP originating from R2 lists R1 as an adjacent router, specifically the circuit ID 2, as well as the 192.168.1.0/24 prefix, which is the network over GE000.0 that the routers are connected. Finally, let's take a look at one more operational mode command we can use to monitor and troubleshoot ISIS. We can view statistical counter information about the types of ISIS PDUs sent and received by the local router using the show ISIS statistics operational mode command. We see in the table that we have each of the ISIS PDU types listed, along with the operations of each, whether they were received, processed, dropped, sent, or transmitted. An important part of this output as well is at the bottom. We can see the number of times that the SPF algorithm has been run. If there is a flapping link or neighbor somewhere in the ISIS domain, potentially causing performance impact elsewhere in the network, then we would see this number increment quickly. It is normal to see this number increment, as some amount of changes in a network are expected. However, if the number of SPF runs is increasing quickly, then we can be mostly sure there is a flapping link or misbehaving device somewhere in the ISIS domain. I appreciate you sticking with me to review the commands used for monitoring and troubleshooting ISIS on Junos devices. I hope that this lesson has been informative for you, and I would like to thank you for viewing.